Welcome back to Young Engineers of Today. I hope you had a good weekend, and I hope you had a couple of days off because of the snow. I imagine you guys probably did, though, because everything shut down. So school probably did too. Did you guys have the day off? If you go to public school or anything like that? Maybe, perhaps. 2 hour delay. Oh, gotcha. Oh, well. I guess that's better than nothing. Well, let's see here. Traditionally, we would start out the semester with information on how to work Google Sites and make a new site in Google Sites. However, correct me if I'm wrong. Correct, excuse me. But everyone who's here was here last semester, yeah? Raise raise your hand if you are unfamiliar with Google Sites. Okay, I didn't think so. No hands. All right. Well then, what we're going to do is we're going to go ahead and we are going to skip that. And let me give you an idea of what we'll be working on instead. So the eventual goal is to, well, is to work to make that, as I'm sure you guys are already aware. The rubber band Gatling gun. However, what we need to do is we need to learn how to work with 3D modeling software so that we can, in fact, make something like this. And to that end, we're going to familiarize ourselves with Fusion 360. Fusion 360 is a pretty competent 3D modeling software, pretty powerful, although the tutorial that we're going to follow, the presentation and everything like that, is going to be about building a bookshelf, and it's going to be a slightly changed bookshelf from what we have in the presentation. It'll be shrunk down and everything like that. I think I'm going to update those as the days go on so that they will be more relevant to what we're looking to do. But yeah, that's what we're going to do. So let me go ahead and get those presentations up. We'll walk through the process of getting Fusion 360 downloaded and prepared, because that's not something we're going to be able to start on today. That's going to be something we're going to have to basically spend today downloading and installing, and then on Wednesday we can get started with the actual class. So without any further ado, let me, yeah. It is, in essence, how we had to spend time getting that prepped and ready before we could get started on it. So let me go ahead and pause my screen so you cannot see what I'm doing. And let me pull up the presentations. Rather, I must have put it into one presentation and just made it a million bajillion slides long. Let me see. Looks like I did. Haha. Good work, me. Yeah, so this is just really big. Really big. That's okay. That's half the fun. So this is specifically meant for CNC machines, but this can be applied to uh, really anything: laser cutters, 3D printers, CNC machines, um, anything like that. So, apologize. Some stuff related to my other job just popped up. I have to resolve this really quick. This is the wonder of having two jobs. Okay, apologies. Anyway, CNC machines, 3D printers, laser cutters, vinyl cutters, I mean, less so vinyl cutters, but regardless, um, milling machines, all of these things are basically machines that can be used with Fusion 360. But what exactly is Fusion 360? Well, let's spend some time talking about 3D modelers, hopefully. No, this is generally a focus on CNC machines. Well, let's spend some time talking about 3D modeling software at any rate. 3D modeling software is, well, just like it sounds. We've got CAD programs, which are computer-assisted design. And all that really means is the ability to create 3D anything, 3D diagrams, 3D designs, anything like that using computers. It's computer assisted or computer aided. Fusion 360 falls under, yeah, blocks. Yeah. Fusion 360 falls under the category of CAD programs because you can design things with Fusion 360 and the computer helps you out with it. Now, it should be said that um, CAD programs can fall under basically a spectrum of, uh, of different types, ranging from more artistic to more engineering based. On the one hand, you've got stuff like SolidWorks and even Fusion 360 to a certain extent, which are more on the engineering side of things, and then you got things like ZBrush and Blender and Maya, which are more on the artistic side of things. The difference between the two is um, you'll be certain to have more accurate representations using the more engineering-based ones, like Fusion 360 and SolidWorks and things like that. You'll be able to create diagrams that explode, and I mean, uh, basically expanded their component parts and then can be reattached as such. And you can use them for animation and construction instructions and things like that. However, there are tighter constraints to building them. They need to be constrained to sort of mathematical dimensions, and mathematical dimensions doesn't exactly mean anything. They need to be mathematically sound and constrained to dimensions that make sense. Like you can't make weird non-Euclidean creations and things like that. On the other hand, the more artistically inclined ones like Maya and ZBrush and Sculpt and such, um, you can think of them almost like working with clay and your hands. They're much more freeform. You can create much more organic designs out of them, um, mess with that sort of thing. The designs can generally be uh, much more natural looking and much less constrained. On the other hand, though, um, There's no way to guarantee proportions other than just sort of eyeballing it. You can't really use them for professional jobs. Um, it'd be like trying to make um, a plain turbine part out of clay and just kind of eyeballing it and putting it up against other plain turbine parts and being like, yeah, this looks good. There's no real way to guarantee, other than the fact that it's made out of clay, there's no real way to guarantee that you've made it to the proper dimensions. There could be some abnormalities, imperfections in it, things like that, that would obviously not be within tolerance. So for that reason, it's not good for machining specific things that you need at specific dimensions for technical work. Everything else, everything sort of falls in that range, you know. Fusion 360 definitely leans more on the engineering side, like I said before. So there are going to be tighter constraints. There's going to be some extra hoops we'll have to jump through. Yeah, Rhino's another one that one's more artistically based, right? Or is that one a more engineering based one? Artistically? Okay, yeah, that's what I thought. Um, I've just been wrong enough in my life that, I always second guess myself. Anyway, um, there are some extra hoops. Oh, you're fine. As long as you get the idea across. There's some extra hoops that you'll have to jump through in order to do some things. Like you'll be sitting there and be like, okay, why do we have to, dimension out the empty space here? But it will make sense, later on, and everything will come together and start to make sense so that you can deduce what exactly is going on. This will also be good to talk a little bit about CNC machines because those things are pretty neato cool. And I believe you will be messing around with at least a form of CNC machine when you guys are making your Gatling guns. Right. Boop. Yeah, let me see here. So essentially it was just learning about CNC machines, how they work in creating a project. It's entirely possible that we will, in fact, create this bookcase and use it in lab and get something cut out. If there's time, I can't guarantee anything. I'm just saying that that's a possibility. So that ends up happening. That'll be pretty awesome. If not, well, these things happen. Oh, apologies. I'm still having coughing fits. So intro to CNC machines, what we will need using Fusion 360 and your first project. So CNC, what is it? Well, CNC stands for computer numerical control. CNC machines basically refers to a whole family of machines. It's not one specific type of machine, other than the fact that it's controlled by a computer. But they can be mills, they can be lathes, they can be cutters. The important thing is that the process in the machine itself is controlled by a computer as opposed to human hands. Traditionally, you've thought of lathes as these things that spin, and somebody else comes in and sort of twists some knobs and brings in a little tool and removes a whole bunch of metal to specification and stuff like that. And then they've made it. But, in essence, they've made that by hand, regardless of whether or not they've sort of used a machine in order to achieve those ends and have it be a much more even cut on the thing, or a much more precise creation of a part. In this case, it would be completely computer controlled. Now, CNC machines generally are subtractive processes. That is, they create a design by removing material from a larger chunk of material. A 3D printer would be an additive process, or you would use an additive process. So you'd have some plastic, it would then melt down the plastic in a specific way in order to generate the design. But the actual table that the 3D printer starts with is empty. There's no material on it. They build it from the table up in order to give you your 3D printed model. A CNC machine generally is a subtractive process, which means that you would start with, I don't know, like a cylinder of material, and then the CNC machine would cut away material until you had your design. So they can be thought of as opposites of one another in that sense. Obviously, I mean, the name is kind of a giveaway. But yes, so CNC machines generally are subtractive processes. They remove material in order to give you the desired product. You start with a larger chunk of material in order to get the product that you want, like a lathe or a cutter or a mill. I need to stop coughing. Because CNC machines rely entirely on computer control, there is very little in the way of human input during the actual milling and cutting process. Instead, our input comes at the other end with CAD programs, but there are ways that we can affect the process. CAD programs like Fusion 360. Now, creating something with a CNC machine usually requires three kinds of software. You've got your computer-assisted or computer-aided design programs. It says you should be somewhat familiar, but that's just because Fusion 360 sort of culminated in a few lessons that all involved CAD programs. You guys may not necessarily be familiar with CAD programs yet in an actual like experiential sense. You might know the name and know that it means something like Fusion 360 or Google Sketch or something like that, but you wouldn't necessarily be familiar with CAD programs firsthand. CAM programs, or computer-aided manufacturing programs. Oh, well, there you go. So you're familiar with at least some form of CAD program. If you're familiar with Tinkercad, then yeah. CAM programs turn your 3D model into a set of instructions for the CNC machine, which are usually G-code. Not always, but usually, which is just simply a set of coordinates and instructions. It'll say, okay, you know, I want you to go here, and I want you to, you know, activate the drill bit and do the drilling from here to here, and then I want you to deactivate the drill bit and lift up to here and then move to here and then go back down here and so on and so forth. Very specific set of instructions. Kind of like when you get instructions on your, like when you're going somewhere and you ask the GPS for instructions on how to get there, it will say specifically turn right at this location, then turn left at this location, that kind of thing. That's kind of how G-code works, except it's much more specific than that. It would be like if you were given a set of instructions at GPS coordinates instead of told to turn at specific streets. That kind of thing. And then there's the machine controller. Well, not as much anymore. It's actually much better than it used to be. Used to be issues. Used to be a lot of issues. But you mean coordinates from a GPS specifically? Because that's also gotten better, but yeah, that is still a little bit off. Anyway, the third part is the machine controller, which you can think of like drivers for the machine. Like if you have a new printer or, you know, something like that, you would need to install drivers for it in order for it to talk to your computer. That's what the machine controller is, in essence. The machine wouldn't work otherwise without the machine controller, so you need all three of these essentially working in tandem in order to be able to create something. Now, you may be able to design something made with a CAD, or excuse me, download something designed with a CAD program off the internet. So you personally circumvent that step, although somebody else made it using a CAD program, so it still basically holds up that you would need all three steps. Now, yeah, again, examples of CAD software. Freeform ones like Blender and 123D Sculpt. And then you've got, you know, ones that are easy to use with some accuracy like Tinkercad and 123 Design and SketchUp. You got more professional ones like Fusion 360 and SolidWorks and Libre. And you got computer-aided manufacturing software like MeshCam, which works across many platforms, or VCarve, which is good for the ShopBot, and other plans, which is good for the other mill machine. And then machine controllers, which are machine specific or specific to operating systems like Mach 3 or Linux CNC. Excuse me. I have something stuck in my throat. And I cannot seem to get rid of it. Okay. I think things are better now. Here we go. Just the remaining sort of sickness that I'm dealing with, I guess. Now, thankfully, most software has had at least a couple of these steps integrated directly into them. So, for example, most CAD software will export directly to G-code, which is essentially like having a CAD or some CAD software and some CAM software rolled into one. Now we're not gonna go over the entire process. We're gonna go over. I mean, we might go over the entire process, but we're at least going to build the bookshelf in Fusion 360, and then we'll go from there. First, though, we'll go over some different kinds of cutter shapes and everything like that, and what makes up a CNC. So since it's a subtractive process, you do need something to remove material. In this case, they are cutters for essentially a mill. So you've got flat end mills, which are a type of cutter. As you can see, they've got this flatter sort of end to them, although it's not entirely, flat. It's still got to find purchase in something to cut it. You've got ball end mills, which have more of a drill look to them. And those are just a couple of different types of mills. And then you got to wonder or worry about flute length, which has to deal with the actual spiral of the mill. So the flute length is how long the spiral is, although you might have, different types of flutes as well, whether it's the direction they turn or if they have much of a spiral to them at all. And you've got taper end mills, mills that taper at the end. The number of flutes is obviously how many times it spirals, or no, that's the number of protrusions. So as you can see here, this actual bit right here is part of a flute. And we've got this is speeds versus feed rate refer to the different parameters that can be used on a CNC machine. These are things that can also be affected by the end user. Well, no, sorry, the person using the mill. Not necessarily the end user. The end user might be the person who's, I don't know, receiving the product at the end. But at any rate, speeds would be the rotational speed of the cutter in revolutions per minute. So how fast it spins. Then you got the feed rate, which is the speed that the cutter is moving through the material. So you can have a high speed and a low feed rate, or you can have a low speed and a high feed rate. That one's not necessarily recommended, but you could. Excuse me again. But these two things can be adjusted in order to compensate for or account for the material that it's cutting through. But it does matter because you want to avoid broken cutters, and if you move too quickly, you can lose accuracy. If you move too slowly, you can waste time. If it's spinning too fast or not fast enough, sometimes you can remove more material than you intended to, which results in a poor looking finish, although it tends to be cleaner with a faster feed rate, but that's not always the case. Now, what would the correct speed and feed rate be? Well, there's no real easy answer to that. Generally, you want to go with the recommended setting, though. That's probably the closest thing to an easy answer. Because a lot of these programs, especially if they're provided by the manufacturer, they will provide recommended settings, and then modify them using common sense. So you could say like, oh, okay, this is going pretty slowly, but it seems to be coming through okay. Maybe we can try speeding it up a little bit. Or, oh, you know, it's having a hard time cutting through the material maybe because I'm not giving the mill enough time in order to move away material before it starts trying to move through the material that exists. So in that sense, you know, I might want to slow it down, that kind of thing. So just basically use common sense. Excuse me, I'm going to get some water. Some of you might be saying, why didn't you already have some water? To which I answer, I did, but this thing is not going away, and I actually already killed that glass trying to make my throat calm down. But oh well, here we are. So CNC machines can also work with a variety of different materials, including MDF, which is medium density fiberboard. This is, you know, basically just a kind of like plywood, sort of. Plastics, wax, for real, but it has to be machinable wax. Foam, polyurethane tool boards, which are also kind of like plastics, but they're much denser. And metals. We're going to create a simple bookshelf in Fusion 360 and get it ready for CNC milling. It won't be anything crazy fancy, but something that we can use. So let's go ahead and open up Fusion 360 for now. Let's go ahead and get Fusion 360 downloaded and installed, which is probably going to take the rest of the class, and that's okay. So what I'm going to do is I'm going to do a Google search for Fusion 360. And I'm going to go ahead and go to the educator one because, or the student/educator one, because that's going to be the free version of Fusion 360, which Fusion 360 is not normally free, but, well, I mean, some versions are, some are not, but anyway. Once you go there, you'll be looking at this site. I'm going to go ahead and click on Create Account. I already have one, but I walk you guys through this process. Country of educational institution. Obviously, we're in the United States. Go ahead and select that. Educational role, you're going to want student. And then, let me just double check this here. Oops. I wonder. Yeah, you need to be older than 13. Again, I don't think an issue you guys are going to run into, but just, you know, in case. Let me see if you need to be older than 16. Oh yeah, you don't need to be older than 16, you just need to be older than 13. That's fine. Once you do that though, go ahead and enter in, you know, your information for logging in and everything like that, because you'll need to use that when you're first starting up Fusion 360. What's up, Cohen? That's why we're creating an account, so that you can use it. That's actually the purpose of this right here, is to create an Autodesk account. Okay, let's go back to this one. There's no create account button. Do you have something listed up here other than sign in the upper right hand corner? Okay. What do you have instead? Just sign in? All right, let's click on this. Well, there's this create account button right here, link right here. So click that, and then you'll be taken to where we are. What do you mean it's blank for you? As in the pages? What browser are you using? um, are you getting any indication in the upper right hand side that anything's being blocked? Might be in the address bar. Okay, excellent. Nice work. All right, so go ahead and create, or raise your hand once you've created an account. Yeah, you wanna set up an education profile. Oops. Meant to do that. All right, just wait for a couple more hands before we can move on to the next step. Go ahead and use Young Engineers of Today as the name of the institution. Or you can, yeah, once that's done, you can go ahead and hit download now, and it will begin to download it. It'll be a rather quick download initially. Yeah, all is fine. It'll be a rather quick download initially, and then there will be a lengthier one for the actual Fusion 360 material. You don't have to. Just if you want to check for, like, if there's an engineering one, you can check that, or design one, you can check that one too. Don't put too fine a point on it. It doesn't, in the end, it doesn't really matter. I You can just put Young Engineers of Today. There was a download link on the main page. After I'd signed in, there was a download now, which had appeared, and I clicked that. Though I believe if you just want to, you can just click on the free trial and download the free trial, and then you can set up the whole education thing later on. I don't know what you're looking at. Just July of this year. From January of this year to July of this year. Like I said, it's not something you need to put too fine a point on. As you can see, it goes through the process of installing.
Hey, Tom, do you mind if I ask a quick question?
Sure.
Hey, sorry to interrupt. Hey, guys, one question, Tom, Mr. Toy, Tom may have asked, how many of you all have, put your hands down real quick, how many of you all have a PC at home?
Oh, thank you for reminding me.
I didn't say it, I meant to. All right, let me see here. Caleb and Mateo, can you get a hold of a PC? Let me ask Mateo. Mateo, can you get a hold of a PC?
I really don't know. I'm pretty sure we don't have one, though.
Oh, so all you have are Macs?
Yes.
All right.
Okay. Other Caleb Beckstein. Sorry, Gillis.
All right. Who else? I'm going to put the other Caleb right here. All right, leave your hands up, guys. Leave your hands up if you've got a PC. We think we have everybody but. All right. Caleb, do you have a PC? Beckstein. Hey, Caleb.
Yes, he does.
All right, great. Mateo, what we may end up there, but we needed to know that because there's a piece of software that we had used on the ShopBot as you do part of the, I'm sure Mr. Toy has talked about the Gatling gun we're going to do on this. So we want you to be able to learn V-carve. So you may be watching, and I apologize for that. We usually try to use software, but it only runs on a PC. All right? Sorry for the interruption. Thank you very much. But it allows us to plan what we're doing next.
All right, no problem. Thank you, Mr. Dooley.
Thank you, Mr. DeToy. I'm leaving now.
All right. See, even Chris Pratt uses Autodesk. What do you mean? Why don't you put the school that you attend then instead? Okay. Do you have a public school that you can put in there instead? Because you can also add young engineers today to it, but for simplicity's sake, I mean, again, that's fine. But if you've got a nearby public school you can use. Do you have one that you could use? Yeah. Like I said, in the end, I mean, this is simply because you're not able to put young engineers in there. So don't sweat it too much. This last bit always takes a minute. There we go. Sort of, at least it's at 100%. Excellent. Are you downloading it now, Cohen? Okay, cool. All right, so with that then, presumably everybody should be downloading their own copy of Fusion 360. It should probably still be installing, which means that we're not really going to have time to get started with it today, especially considering that it's 8:52. So with that in mind, we'll go ahead and call it now, and then we'll get started on Wednesday with actually building our first model, which will take a few lessons. Mark my words, it will take a minute, but that should be pretty cool. At least you guys will get familiar with it, and it should be neat. But what I'm going to do now is I'm going to go ahead and ask the poll questions, and then leave it open for question and answer time. Again, just because everybody's going to be installing Fusion 360 right now, that took me a good, I don't know, almost 20 minutes. So I imagine you guys are probably taking about the same amount of time to get it installed. But yes, so we'll do that. We'll do question and answer time, and then we'll you know, break for the next couple of days, and we'll meet up again on Wednesday. Oh, well, there you go. At any rate, first poll question incoming.